it's on. Yeah. Hello. Now Eric is telling us something about repeatable functional builds.
Yes. Hi, I'm Eric. I'm coming to you from a lot of time wishing for computers that work, long story short. And this is going to be a talk about that and ways in which I am sad and ways in which I hope to someday be less sad. So this talk is going to start out with a little bit of discussion about ways we use computers today, package management, what role that has in how we use computers, what role that has in how we build software, some things that might be room for improvement in package managers as we know them today. Then it's going to move on to some examples of what it might mean to have repeatable file systems and repeatable computation. Maybe reproducible, but I'm going to carefully consider that a stretch goal. Comes after repeatability. And then I'm going to try to do some live demos, hope that the demo gods are with me, and do reproducible builds on the screen. And then maybe even consider what it looks like to do it well, which is probably not what the demos will be, but you know. OK, so the way we use computers today is, I think often it has a lot of hope and a lot of dreams in it. When we want to use some piece of software, we take our system package manager and we do my package manager install foobar. And then we desperately hope that some binary called foobar ends up on our system, that it works, that it's a recent version, that it will continue working in a couple of days, and we make a stateful change to our computer. And we call that good enough. When we are running tools just for ourselves, often this is OK. Something that's starting to change the ways people use computers is the container revolution. And in this, people suddenly realized, like, hey, maybe my computer being a giant ball of state is like not the greatest. And instead, we started using snapshots in order to distribute known good configurations of our computers. And in some ways, this increased the reliability of our machines. And in some ways, this is exciting. But in a lot of other ways, well, we had some regressions with this at the same time. Now it's become, when we want reliable software, we start shipping around an entire multi-gigabyte image of a complete computer. Why do we do that? So the way we might wish to use computers is something even further. What if we could have snapshots of our systems, but also these snapshots were made out of something composable, something we could understand? So this talk, holistically, is going to be about moving to the right side. Right? Yeah, believe the arrow. To this side. We want to have computers that we can understand and that we can rely on. This might mean something with both snapshotting, but it also means something that is clearly not containers, as have recently been popularized. We might need something new. So this is easier said than done. It's one thing to say I want to understand how my computer is assembled. It's another thing entirely to come up with a tool chain that actually makes this easy. So we're going to come back to this. And first ask another very related question, which is how composable do we expect installing software to be? The easiest answer is always simply shrugging. Use Global System Package Manager, install foobar, and hope that it does a thing. But this has some baggage. If the thing I need is not in my Global System Package Manager, or if I need a version that is not the current one, in a lot of systems, I don't want to name names, but in a lot of systems, this means I have to give up. I see there are some people from better distros in the audience, and you might be snickering at me, but I'll get back to you. Much later, though, because that is a better system. So if I'm having a hard time using my Global System Package Manager, the one that thinks it owns slash and above, maybe I'm going to go to containers again. They've given me a way out. And I'll just run all the same tools I used to, but I'll run them in a container. It'll give me snapshots, it'll give me isolation, it'll be fine. But there's baggage to this. Now I'm managing those whole system images again. This isn't composable. So if I start with the goal of simplicity and having a system where I can just install what I need anywhere on any machine or on any path on any machine, well, now I don't have any baggage. Now I just have an absolute lack of tools which can do this in the world today. It means I want tools that allow me to install libraries that are conflicting, but it shouldn't be a conflict. Where did we ever get this idea that installing multiple libraries could be a conflict? We need tooling that's better than this. So this talk is, again, going to be about moving towards the right side of the screen, moving towards things that are simplistic, things that are aiming to be actually composable. And this is going to require some tools that maybe we don't have yet. So we've got work to do. If we want to drive reliability up, and we want to do it with something that's better than snapshotting, we have work to do. And what we want to do is probably something in the general description of reproducible builds. I'll come back to defining this better later, but repeatable, purely functional builds would be a lot more comprehensible than global stateful modification to my machine. And if we want things which are composable, we have to get away from the awkward bandage that is containers and chroots. They are a way to staunch the bleeding, but fundamentally a chroot to pretend that I have a whole system so that I can install things that are global on my system in a way that's not actually global on my system. These are epicycles. We need to just fix some of our fundamental problems. And so I think we need to talk about standards for installing things which are path agnostic and which support co-installable libraries. So how do we proceed? These are two really large concepts each, and both of them need to be solved. This talk is mostly going to be about the reproducible builds components. So let's define that better. Fortunately, there are a lot of people working on reproducible builds at this point. There's a whole organization that is meeting a couple of times a year. If you dive into this reproduciblebuilds.org site, you will find connections to many people who talk about this and care. And fortunately, they've given us a definition. A build of some software is reproducible if, given the same source code, the build environment, the build instructions, anybody can recreate bit-by-bit identical copies of the outputs. This is a definition that is, again, sort of easier said than done. It's great that everyone agrees that given some source code and some tool chains, we should have bit-by-bit identical results, things we should be able to hash, in essence. But it's really difficult to make an operational definition of the first half of that sentence. The same source code, well, that's easy. We have tarballs from the GNU sites, or we have git checkouts from wherever. These are things that we can identify pretty easily. Build environment and build instructions, that can be quite slippery. So I would like to introduce a new word to describe that entire first part of the definition of reproducible. There's something we need first. We need repeatable. And that can cover a lot of things. If we're building some random C project on the internet, we need the source code, yes, but we need the GCC or the Clang. We need the linker tools. We need possibly auto tools, or perhaps automake, or autoconf, or CMake, or we need a very large amount of build environment. And the details of the instructions are also, it can become extremely detailed. If you're requesting for bit-by-bit identical results of some builds, all the flags matter. You cannot just forget to document your dash dash anything. So this is where we get back to things are easier said than done. Again, sort of a recurring theme. We know that we want reproducible builds if we want understandable systems. And we know we probably want some repeatable builds in order to get reproducible builds. And I would go one step further and say, we want all this to be easy, because I would really like people to actually use tools to make reproducible builds. Which means we need to automate things quite a lot. A bunch of readmes in Markdown in prose that tell you what version of GCC to install are not good enough. So let's make some tools. I would love to have some tooling which is basically pure functional programming brought to building everything. That means we need to have a list of inputs to the function. We need to know what the function, the build instructions themselves are, and we should be able to list the return values of the function. And I've made a tool for this, which is called Repeatr, which I am going to demonstrate to you in the next couple of slides. This is something that you could squint and you could see Lisp. But instead, you should squint and see JSON, because I would love to have some repeatable build tools which are powered by APIs. And to that effect, this is a JSON object which is called a formula, which can be handed to the Repeatr tool. It contains all three parts of your lovely functional programming language: the inputs that you need, the thing that we are going to execute, and the output that we are looking for. This is something that is about to turn into a live demo. And when it does, it will run in a container so that all of these operations are defined. In this case, the operation is a very simple makedir. And the binary to do it is going to come from what's unpacked at / in the container file system. And that is going to be fully described by this hash on the end. Sort of skipped over the introduction to the hashing part. It is necessary, if we are going to have purely functional builds, that we should have pure and well-known inputs. So we're going to put a hash on it. And this is something that should be executable. So let's see if I can switch workspaces and get something to work. This is the same thing getting ready to go in live demo mode that I had on the screen a moment ago. And a tool exists that will execute it. This is a simple operation like makedir. It is indeed reproducible. And so when I evaluate this thing, a whole bunch of work goes on behind the scenes. Repeatr is one process in the POSIX sense. It is going to launch one process which goes and unpacks this content addressably identified hashed file system, launches a container, afterwards packs things up again, and hashes them. If I run this repeatedly, I expect it to do the same thing. And so it does. Where did my slides go? Right. So this is a very simple thing, doing very little work. But the essence of what it's doing is anything that you could evaluate in a Linux container, and you can have as many inputs as you need to the system. As you can see, this is a JSON API with a map, right? So if you want to mentally compare and contrast with other container systems, you are not stuck with monolithic images here. You can input as many file systems as you need under whatever paths you need. And when you Repeatr run this document, you will get all of those file systems. So yeah, let's jump ahead one demo. Something you can do with this is switch to YAML, because it's a little less painful. another demo I can run is having the repeater tools build the repeater tools. And in this example, no, maybe. I'm going to compile some programs in Go, and to do this, I have more than one input file system, and I want to compose them separately for purposes of both efficiency and my sanity. And so I have an input at slash. This is going to contain some busybox image. At another path, I'm going to put the Go compiler. This is some horrific piece of templating in Bash. This is one of those things that works and is nice as an example, but maybe some better APIs should come along. But it's a great documentation. And this particular thing is also going to build, given some hash of a git commit from GitHub. Anything that can be identified as a hash can be used as an input in Repeatr. There's a whole plugin architecture here. So tarball's convenient. Git repos, I heard that sometimes people use those. And this particular build is going to output one subsection of the file system. So again, contrast with other container systems that you might know. It's quite common to take one monolithic image in, do a bunch of use your distro package manager, global side effects thing happens, lots of time is wasted, you do who knows what with the network, and then you save the entire root file system again, and everything in it, all of the changes. And in other container systems, this is all you can do, and it's slow, and good luck explaining what happened, right? You can run diff on those two monolithic tarballs at the end, and the diff will be bigger than each tarball, and you will have no idea what happened, right? So with Repeatr, we've designed a little differently. So you can extract just the sections of the file system that you care about, and of course, you can select several of them. So if you have binaries in one place, logs in another, separate them. So now if I want to run this demo, I'll skim ahead and warn you that there are 1, 2, 3, 4. Yeah, there's 4 different things built here. And then there's a 5th formula, which is now taking all of these other inputs together. At the end of every one of these, horrible bash hacks. Did I run the individual demo? So when I run this individual demo, this is JSON in, JSON out, right? This is absolutely meant to be a low-level programmatic tool that you should use with some other templating system on top. So it's going to spit out JSON at you on standard out. These other log lines above it were all on standard error, so just discard them. So when I run this larger script that's taking a whole bunch of things together, it's taking the JSON. It's using JQ. I assume most of the audience has seen that. It's like a streaming query selector thing for JSON. So it's going to take the results object and its key, shove it into a bash variable, and template. Yeah, horrible, horrible bash. But this is something that I can run. And it just built all of these containers individually, and it did so instantly because, well, it didn't actually do anything. You see, this whole formula document, since it is composed of a bunch of hashes, and this bit in the middle is a static string, right? We can take this entire formula, and we can serialize this in a deterministic way, and hash it again, and we have magical, perfect memoization. So this whole process just completed instantly because it remembers having run before. If I, where did I put it? Throw away the previously existing memoization and run it again. Yeah, a little less instantaneous. This is now running the Go compiler for like 4 different binary components of the Repeatr toolchain, and should spit out a binary soon. Yeah. So this is the overall hash of that system, and this is actually, if you go to the GitHub page for this whole project, the release tarball right here is going to have the same hash. You can download this release tarball, open it up, get the binaries in it, go to the same bash script, and I dare you to rebuild this. You should get the same hash. All of the tool chains are pinned, and as long as you are starting from something that vaguely resembles a Linux kernel, you're going to get the right thing. Or if not, like, you should actually like tackle me later. Tell me what different hash you got. Somebody compromised my kernel, your kernel, something unbelievably strange happened. OK, back on track. So why is this cool? We can do a lot of things with this basic primitive, I hope, because all of these formulas are a completely specified context. The value and version of the compiler that I used is not in question. It's specified by hash. It's immutable. Because all of these things are specified by hash, there is no further trust required. This is something that can be completely decentralized. I can actually expect anybody to, like, you can paste these formulas on pastebin, and as long as somebody like roughly trusts that first handover of the document, you can build everything specified, and you don't need any mirrors which are trusted at all. And like, maybe most importantly to my personal sanity, I can assume that I can give you something and it will work. Because everything is running in a container, and all of the inputs are whitelisted, all of the outputs are explicit, I'm like pretty sure that that's going to work. So I already did this demo with bash and JQ, so I'm going to skip that. And with this, I would hope I can just hand-wavingly say, we could build anything. You probably wouldn't want to do it with bash. It'll get old fast. But you could. This is all API-driven. This might be a good time to pause. Are there any questions that anyone has at this point? I'm just like flying around through demos.
Yeah, so can you face my Take this one.
Oh, okay. So you mentioned like memoization and deterministic hashing and stuff. And so like with other container systems I've used, and I think a lot of people have used, if you rebuild like an image, it'll cache it, but if you like clear the cache and rebuild it again, it comes out with a different hash. Because I mean, you do like an apt-get, and the thing it does today is not going to be the thing it does tomorrow. So does this tool have the same kind of thing with the the hash is changing if you clear the cache, or does it come out exactly the same again?
That's a good question. It depends on what you're doing. This is sort of the warm-up that I was trying to sneak into the first half of the talk. Repeatr and its ecosystem is full of things that will use lots of hashes. And if you do sensible things inside of the Repeatr containers, it will definitely be reproducible. If you do nonsensical things inside the containers, there is no salvation that can like magically come in for you. So if you're doing like apt-get install, for example, you are, I don't know if I want to say doomed, but yeah, you're doomed. Unless you use snapshots.debian.org, for example, which is this really interesting service they have which can lock things to a set of packages by date. And we assume that the operators of snapshots.debian.org are truthful and honest and returning packages snapshotted from that date. But, well, you should run those processes in Repeatr and watch the hashes that come out. And then you can know more fully whether or not you trust that service over time.
So basically, as long as you do sensible things, then you'll get the same thing every time.
Right. The tool is called Repeatr so that it helps you repeat things. It is not called Reproducer. Please do make reproducible things.
I would also have a question.
For example, what will happen to things I build with GCC? Normally, there would be some build time and other information depending on my current system on that. So that would also change the output, right?
Yep.
But that's basically just another case of that sensible things you should do or should not do.
Right. I don't want to call GCC nonsensical, but yeah. So the lovely folks who work on the Reproducible Builds organization have a decent amount of documentation about things that are frustrating. This is a really great website. And a lot of these things address GCC is kind of noteworthy for embedding build paths in a lot of places, or like giving you flags which let you do this, which is bad enough. All of these are things that need to be fixed in build scripts around the world. So yeah, so Repeatr is not a magic salve to do this, but what I hope is that it's a good tool chain for putting these things in. And now that we run them, and the natural thing you see every time you run a process is the hash, I hope this can incentivize some discussions about these things and like make us all culturally aware that like reproducibility is important. If you don't have it in any small detail, it's really hard to justify the rest of your system, and yeah, and get better from there.
You mentioned that it was hard to figure out what is going on in the Docker images, but or in other containers. But don't you have like the Docker file to state that to some degree?
Yes and no. So you could make a totally awesome, super pure, no side effect Docker file. It's just that almost everything about that format is going to encourage you to not do that and to be super messy instead. Because the thing that Docker does constantly is export the entire root file system, like that undermines you at every turn. I think there are some systems now for multi-step Docker builds using some like -- from commands, and like they're trying to get there because it's like an obviously sensible direction to go. Make your images smaller by not shipping the universe that you built with, right? But it's so high friction to do this that like you can try. I just like good luck, Godspeed. There might be easier tools.
The first example you gave with the mkdir, was that actually reproducible, or like, are you doing something to have the mtime be normalized there? Or?
Oh, good question. Yes, I am normalizing mtime because that thing is a monster. Yeah, so some of the formats I'm using here, this tar plugin that is kind of your default for a lot of the work that you would do with Repeatr in practice. It will preserve mtime and it will preserve UID, and it's literally a tarball. It's like standard tar. But the default behavior is also to flatten most of the attributes that are irritating. Like mtime is set to a flat value, and UID and GID are also, like, usually when you're passing things around between a bunch of images, those just aren't useful. You can add some flags to keep these permission bits. So if you are capturing like the base image out of a Debian system for passing it on further, you probably do want to keep all of the UIDs because reasons, like it will not go well if you discard them. But the default for like intermediate processes in almost anything else, like I think it's sensible. Yeah, good question. Yes, Myhre is non-deterministic on a regular system. We have a lot of cultural rethinks to make. But yeah, flattening mtimes also very rarely causes trouble. It should also be mentioned that if you make the syscall to get the C time out of any of these inodes, you're going to, don't worry about it. OK, so slides, come back. OK, so I have one more layer of magic sauce to toss onto this. So bash and JQ was a way that we could template things, but honestly, that is terrible outside of demos. So if you wanted to use some higher level tools to build more complicated pipelines, there are additional optional tools that work around Repeatr that you might be interested in. So again, all of this is API powered. Repeatr is a toolchain you can use standalone. Even this component alone does the file system components. You can use it separately. You'll get like a nice PS tree if you're looking for it. So this is an optional layer on top of it with a working title of Stellar. I don't know why. I'm bad at naming. And this is a bit like the formulas earlier, but now giving up on pure hashing and moving a little bit closer to naming things. And this is a system that's going to keep more metadata associated with things. And you could conceivably, this is starting to angle towards building a distro or a package manager of some scale. So this is an example that's going to refer to some catalog, which is a way of associating human readable names with hashes. And this is a pretty simple thing. Human readable name, release name, hash. Oop, wrong example. Ah! So this is a system that will go look up this catalog, turn this into a hash, substitute it in, and the rest of this still looks like a formula. And when you run this tool, it will invoke Repeatr for you with all the templated results. That was kind of boring because it was just one. This is a system that can actually do multi-step builds as well. So this is a much more complicated example where we have more than one formula template. It's even a recursive system, which has locally scoped names, can refer to parent scopes, etc. I'm skimming over this really fast because I think the core of Repeatr is more interesting. And if anybody wants to do experiments later, they should use that first. But if you also are looking at that and you're thinking, wow, that's way too many hashes, I'm afraid I'll get stuck copying and pasting. I hear you already, especially you, laughing person. Yep, you're right. It will get old. So here are some tools that fix it. This can even go so far as to have some very impure ways of interacting with the world. So this system also supports ingesting things from Git, for example. So this is a command that instead of looking at some static release catalog, is going to look at my local impure state, use a Git system, look right here, look at head. And it will template this thing in, run a formula based on this. This formula said hello, and it LS'd the source tree. And indeed, a readme.md is the one thing this contains. So this is a system that you can use to basically do CI on localhost if you want. I don't think I'm going to demonstrate that in entirety today, but like, imagine putting a bash while true around it, and now you have CI on localhost. Slides. So what can you do with that? That format was meant to introduce human-readable names again to the system, and it's just one example of how you could do so, because again, Repeatr, API-driven, build your own magic on top of this if you want. But if you do use this system, the idea is not just to give you human-readable names for smoothness, it's that those pipelines, they can be used to build something. But if you had a complex build and you wanted to ship the whole thing to somebody, they could be used for rebuilding it too. As long as you have the same reference to the release catalogs to supply all of the basic hashes, and you could vendor that into your Git tree. It's pretty lightweight. It's just text files. then anybody could rebuild given that snapshot of the releases and this snapshot of your module. This is something that I would love to turn into a distro, basically. If you so much as, let's have less git in there. If you vendor these files into a Git repo, and you have the module in the Git repo, you have a reproducible build, except for maybe just this one thing. We could mechanically transform this thing too, because this is all a JSON API. We can reason about this very clearly. I could take this ingest Git thing, and I could have a tool automatically rewrite it to just be the current Git hash. And I could pin that in a file. And I could put it inside, let's maybe say I would make a sibling of this. And I just store the module in there again. That would make this whole thing reproducible, assuming, again, that this is a reasonable script. I could now ship a single Git repo which has tons of internal dependencies, very complex tool chains, and I could expect that the whole tree is reproducible. Maybe that would be cool. I'm going to leave a whole bunch of that as exercise to the reader. Right. So we had hashes. Going way back to the beginning of the talk, repeatable, purely functional, hopefully reproducible builds are one of the major things that we would like to improve in order to get a world that we can reason about. The other one is, and like some of the questions in the middle we're aiming at, we still kind of have this problem where we're using these massive global system package managers to have wild side effects so that the only thing we can do is snapshot the whole base image. And we need to get better at that. And so we really need some standards for being able to install multiple versions of libraries, multiple versions of binaries, wherever we want. In some of the examples I had earlier, this was super easy. BusyBox goes there, fine. And if I'm using the Go compiler, this is a particularly well-behaved thing that I can drop in any path, and it's going to like do the thing. Not all things are so well-behaved. If somebody can give me a GCC build, for example, that can be dropped in /foo/GCC and can also be dropped in /bar/GCC, and it still works, could someone please give me that? I don't think it exists, and I think we need to build it. Good. Give me links to that later. It has to exist. I can't be the first person to wish for a portable GCC build. So not just with GCC, though. I think we could really do well by seeing this for pretty much anything. Right now, we're still really stuck, even if there's a couple of things somewhere which are built in this path-agnostic portable mechanism. Most of the time, if I want to do real work today, and I'm working in some desk job in a company that has lots of other priorities, what I'm going to end up doing is running some global system package manager inside a container and snapshotting it. And it'll work. And that's probably what I'm going to do if I'm pressed for time. But this is not helping with our goal of having simple things that we can actually reason about. I think I'm sort of running out of time on this, and I just simply didn't prepare enough slides. But if anyone wants to talk about this after, you'll know where to find me. And there's also another talk coming up at All Systems Go in Berlin in a couple weeks that's going to be about this whole topic of path-agnostic binaries and general tools. And the one thing I want to leave with today is we should assume that this is doable. And I think Repeatr could be another tool to help do it. In the same way as having a hash printout at the end of every step can be a cultural aid towards making reproducibility the default, wouldn't it be cool if we could make some general linting scripts that install a command in a couple of different paths and make sure it still works, or install it with and without these libraries in certain paths, make sure it works. We could have linters for the portability of our binaries. That's all I've got. Thank you for your time. If there are any more questions, I guess, sure. This is an HTTP link because it is on GitHub pages because I am lazy. Oh, well, I maybe haven't updated that doc site in 2 months, so but thank you for the note. I will try to fix it.
Sorry, I just noticed recently, I think it's a year ago or so, that Red Hat added a unique build ID to their RPMs, which by definition is not repeatable builds then, because do you think that's the right way to go?
No, absolutely not.
So for part one, my question is if you ventured into source-based distributions at all, in particular if you have some experience using the Gen2 Catalyst tool or the Fun2 Metro tool. And for part two, I was thinking about NixOS, which seems to be also somewhere in this direction. Okay,
those will have a lot of, there will be a two-part answer as well. So source-based distros. Gen2 is beautiful, Fun2 doubly so. When I build things, I look to them a lot for reference because a source-based distro actually involves people exercising the source so you know it's going to work. This is not true of all distros out there. I think the direction I would like to see development go in the future is actually breaking down the distinction between source-based and binary-based distributions. If we have fully reproducible builds for everything in the distro, then the distinction becomes completely nebulous. It's a trade of, do I want to use the network or do I want to burn my CPU locally? I'm so excited by your nodding. To the question of NixOS.
There was also the question about tools. So have you seen or tried the Catalyst and the Metro tools?
I don't think so.
All right. I can show you. They do a lot of this on the, like using, so you provide a spec file with the packages that you want and it runs the package manager and it builds one full system with exactly the inputs that you give it and with the regular package database.
I will be interested to see how deeply true that is. And
it's
I don't
pretty
mean to,
true.
Right. So I don't want to phrase that as like a combative thing, but this is also something that a bunch of other distros have claimed to have, and it's usually a little. With Repeatr, you have hashes for everything, and that is like almost a religious level take on the scenario. There is no trust of mirrors. Anything else that does trust mirrors is interesting, but a different kind of tool. I don't know if that is actually a fair description of the things you're naming.
No,
Maybe
not
not.
really. Let's
good.
look at it after.
So great. I look forward to hearing about this afterwards.
All right, but then NixOS, yes.
So NixOS is also a really cool distro, and I think they would also be super on the page of like functional builds. I think I hear them say this a lot. Treating compilation as a pure functional system is, I think, just at this point, clearly the way to go, in part because Nix and the Geek systems are being so very successful and so very productive compared to some of the other distros out there. There are also some very interesting choices that I think could still be improved upon, especially when it comes to this composable installation part. And I really skimmed over this too fast because I didn't know if I wanted to spend a huge chunk of time on it in this talk. But distros have a tendency to be balkanizing just by their very nature. If you take any two distros in the world, they might not have intended to come up with such very different solutions to things, but inevitably they do. Binaries on Debian are not portable to Ubuntu systems, even though those are very close. Binaries on Fedora are not portable to CentOS, and quite interestingly, binaries on Nix are not portable to Geeks and vice versa, even though the tooling is almost exactly the same at the lower levels. The reason for this is a whole bunch of legacy tool chains and basically things from the C ecosystem and the way we do dynamic linking. Everything links with absolute paths. The Nix and the Geek systems have this really cool approach of linking libraries in sort of content addressable paths, which actually gives them, what was this word that I used a million years ago? Nix and Geeks have co-installable libraries because they use this sort of content addressable path. But it's sort of content addressable because it's based on the source hash, and they just assume that all builds are reproducible and nothing can go wrong with this. And I think that's a little interesting. And despite having co-installable libraries, neither of those systems came up with path-agnostic binaries. If you install Nix in /Nix, you're fine. If you want to install Nix in /home/myuser/Nix, you're going to rebuild everything. Or you're going to use an ELF patcher, which is like, I'm just going to call that interesting again. And I think this is a problem that is not necessary to have, and I would love to build a system that doesn't have it. Sorry, that was a lot of words off the cuff. I don't know if...
Thanks. So the path, you said explicit or full path for the linking, that's only the case if I link with RPath, right, in the C compiler. But I don't know how common that is actually, if it's the norm or if it's
I think it's
not
the
yet.
norm if you don't. And it is possible to use RPath in such a way that you get path-agnostic binaries, but it's quite fiddly, and I very rarely have seen people do it. And I don't think it's definitely not common in any of the popular distros today.
Well, so the way I understand RPath, it's actually the opposite. So you have to sort of opt in to lock a binary to a specific library.
I wish that that was true, but run LDD on anything on your system and tell me if the paths start with / or not.
Those paths are generated by ld.so according to the search path that is configured for ld.so, assuming and of course taking into account any RPath markers in the libraries, like recursively, so to say. So if a library in the search path references a specific full path library, then yes, that will get pulled in with the full path. But if none of my shared libraries and none of my binaries have RPath specified, then it will just do whatever the runtime configuration says, as far as I know. That's the ld.so.conf, right?
Ooh, that's interesting. But that does not...
So if you can compare LDD output with readelf output, right? And readelf will say the libraries that are needed, and sometimes with path if it was compiled and linked with RPath. But I think most of the time without a full path, and then the dynamic loader is just searching through the system search path to find those somewhere, anywhere, and that's why you can also set LD library path to mess with or like influence what gets loaded when and from where.
You can definitely use LD library path. That linker has many, many features. What it can do and what would be wise to use gets fiddly fast. I
guess I'm not disagreeing with you in any way. I'm just saying the path agnostic
Where do I wanna go?
binaries, to my knowledge, it seems to be more common than not. But there is no standard, and I think that's a good point. Like it's worthwhile to have a standard on that, and like to clearly specify whether this is path agnostic or whether or not. Right? Would be useful.
Right. I guess my main hope and goal would be, we should definitely talk a lot more after this. I would love to come up with like linter scripts for what this means, because it is easy to talk about and hard to prove in any direction.
Cool.
Thank you for these wonderful questions. Oh, jeez.
So I actually tried to check this, and like for example, my GCC, the only absolute path it has is the LD Linux SO, but like everything else seems to be no R path. So you just need to use Gentoo, then it's all right.
Yeah, okay. I should spend more time on Gentoo. Maybe true.
And it seems really that he's right that most binaries don't have any reference to userlib or anything.
In some cases, even if you have relative paths, then like what exactly to do with them is an interesting question. Like, I don't know the name in Debian, but there's some sort of like a life cycle event in the distro where we're doing a sufficiently large change to some library version where we're going to bump the number on the end of the .so path, and this can create like a large amount of discussion because it's going to propagate a change or break things, or it requires a lot of people to sit up and take notice. And I think that is semantically very, very different than what we see in Nix and Geeks, for example, where this is just a non-event for them because they have this pseudo-content addressable linking. And I like the latter end of that spectrum a lot more, personally. This can get into even more interesting discussions. Yeah. Oh, God. Can I declare a last one? My throat's getting awfully dry.
Yeah, I was just wondering about the content addressable part of this, where Repeatr is finding its inputs that are specified by hash, and also if you have looked at like other content addressable systems like Camly Store and IPFS, which have both made what I think is a good choice of supporting different hash functions and having that be part of the address, the name of the hash function.
Yes. So let's see, which is the most interesting screen? So these hashes are of some format which is known to Repeatr. The most important part, in my opinion, of the way the system is implemented right now is that there is a plugin structure there. So this is some simple deterministic way of hashing tar contents. And earlier I showed like Git is a plugin as well. I would love to support tons of more systems. As long as something is a hash, I am perfectly happy to put it in the middle of a formula, and then I hash the formula. This is still a Merkle tree. And as long as I have a Merkle tree in my formula, I'm super happy. I can work with that. IPFS is like not a deeply natively supported thing right now, but you could actually use an IPFS mutable directory and like drop the tar transport on a local path inside of it, and it would work. Sometimes I do this. The IPFS thing in particular could use a few improvements to the UnixFS file system spec, because right now it is not maintaining things like mtime, for example, and that's, I would like it to. I feel like there's a second half of that question, and I've forgotten that clause.
Where it's actually getting the,
the
input from.
Right. Good question. So even in a content addressable system, I still need like some general idea of where in the universe to look. The hash is for identity, but that, like, I can't just scream into the void, somebody give me 6Q, 7G, you know. So in this document, there's actually two halves. This top half that you feed to Repeatr is the part that is intended to be hashed, and this bottom half is not. This is full of URLs and extra context information. So in this case, I told it to just use a local test file, because this is one of my fixtures in CI, so I don't have it network at all, right? If you jump into using the higher level systems, where is my best demo for, right? If you want to use this Stellar tool that does the modules and the whole catalog release system, then that gives us room to put more information alongside. So like with this busy bash thing, there's a hash of the thing, and here's a list of places where you can get it. In this case, it is some, this prefix means run in content addressable mode, so like mangle the hash and put it on the end of this URL and then go there. And it applies for everything of pack type tar in this whole module. Some other systems, do I have? Right. So another thing that I have a release on hand here is the Go compiler, because I use that a lot. This whole thing is built in Go, and the Go compiler is deterministic, by the way. It's really nice. So in this case, I actually have it pointed at all of the upstream URLs of the Go releases. So in this case, I can't use the content addressable mode because that's not how the other people organized it. But I can index things by the full hash. So yes, that information about where to go get the thing has to come from somewhere. Architecting the system very carefully so that that ends up on the side rather than anything that ends up in a Merkle tree that is like the definition of what's going on. It's sort of like a very difficult API design thing, but very important. All right.
Okay.
No more?
Then thank you again, and I'm sure we will have some interesting discussions afterwards with you.
Yes.
Thanks.
Thank you so much, everyone who jumped in. So excited.